Today we're going to do Cisco Nexus Dashboard Fabric Controller for NXOS. In this lab, we're going to show you how easy it is to configure an Nexus OS. Is a classic, is a non-VxLAN fabric using the Nexus Dashboard Fabric Controller. So we'll configure HSRP, OSPF, VPC using the controller, and in the end, we'll verify connectivity using ICMP between the host and that are connected to the fabric. Let me simply show you the diagram and I'll tell you about this Nexus Dashboard Fabric Controller. The NDFC provides end-to-end automation and extensive visibility consistent operations for data center, and it also provides multiple fabric types such as VXLAN, EPN, LAN, IP fabric for media SAN for Cisco Nexus Power Data Center. And in management, Nexus Dashboard's Fabric Controller provides fabric-oriented configuration and operation management, and it harmonizes for large deployments with little overhead, but it also supports traditional deployments like you can see my diagram right here. So the controller also brings an easy to understand and simple deployment approach to bootstrapping new fabrics. And the Cisco best practice are built into the fabric builder policy templates, so you don't worry about anything you missed with those templates. Just with a click a button, you'll launch automatic bootstrap, reducing provisioning times and simplifying deployments. The dashboard also maintains active topology monitoring views for Fabric into new Fabric Controller UI. We have a Nexus dashboard, the version 2.2, and in storage the Nexus Dashboard Fabric Controller app, and we have a EXSI, a vCenter, EXSI 6.7, Windows Server. I'm using 9000 V simulators and a Cisco Cloud Service Router CSR 1000V on the top here, you will see, and CentOS EXSI servers. So what's it gonna do with this lab? We're gonna to build this topology and diagram functions, OSPF, VPC, the trunks, HSRP with Cisco Nexus Dashboard Fabric Controller. So open up my Nexus dashboard. The first thing I'm gonna do is to navigate the services. I'm gonna choose Fabric Controller. In the Fabric Controller, we're gonna navigate to LAN and Fabrics. I'll take action to create a fabric. We're gonna add a fabric name. We're gonna name it as Classic LAN Fabric. In the fabric template, we're gonna make it as external fabric. The fabric template for support Nexus and non-Nexus devices. We're gonna select that. In the BGP number, we're gonna enter 65001. And we're going to uncheck fabric monitor mode. So uncheck this option allows me to configure the fabric rather than monitor it. We're going to save. The next step is to add switches. In the LAN fabric, we'll double click classical LAN fabric. In the fabric overview, and we'll click switches. And in the switches here, we're going to take action to add a few switches. We're going to enter the seeds switches in the inventory management, and we'll enter 198.18.4.101. And the type, we're going to pick an NXOX. And for the username password, we're just going to just enter username and password and click discover switches. In the status of a component is not reachable, we'll click back and then we're going to start discover in the inventory management dialog until the spines and leaves appear and display manageable. We're seeing the leaves and switches are displayed as manageable in status. So we're going to select the manageable components and add a switch to import it into the fabric. So imports the components may take about 1 minute. So when the progress indicator for all components display switch is added, then we're going to close it. Now switch is added, I will close the dialog. When closed fabric overview page, I'm going to show you a little bit to find those components. I'm going to click the topology, double click classic fabric, scroll up a little bit for the leaves. Should do it this way. Open my diagram and pretty much discovered the whole network for this part. Then the next we're going to add CSRs. We're going to in the fabric LAN fabric, I will double click the fabric, the classic LAN fabric. In the fabric overview page, we're going to go to action and add switches. For seed IP, we're going to enter 198.18.4.51-52. In the device type drop down, we're going to select an iOS XE and we'll click CSR 8000V and username password. Click discover switches. So go back to add switches instead of using a -52. I can just use the one IP to add CSRs. Click discover switches. For this time, I'm going to add a CSO-1. Now the CSR is added. We're going to choose it, close it. I'm going to use the same way to add a CSR2. Next thing we're going to do, I'm going to assign the rows to components. So we're going to pick up the leaves and click action, set a row. We're going to pick access as a traditional LAN. And my spine here will be an aggregation switches. Instead, we're going to pick aggregation. For the CSRs, what I'm going to set the role for the edge router. No, it's going to be a core router selected because the current are edge routers. So now we're setting rows down, and we're going to take some action. But before do that, I'm going to go back to the fabric overview. We'll take action to recalculate deploy. Click deploy all. Then we'll close it. So now all component status displays in sync. That's a good status. So after adding the switches, we're going to configure VPCs. Let's review the topology, and we'll see the port numbers between the spines and the leaves. We need those to configure the VPCs. In this lab, we configure two VPC domains. First, I configure the VPC domain 200 between the spine 1 and span 2. Then we'll configure VPC domain 100 between the leaf 1 and the leaf 2. So in this configuration, we cover some VPC concepts. The VPC refers to combine the port channel between the VPC peer devices and the downstream devices, right? And the VPC peer switch is one of a pair of switches that are connected to a special port channel known as VPC, the peer link. And the one device that I configure as a primary device, and the other will be the secondary. And we have the VPC peer link is a link that is used to synchronize that states between the VPC peer devices. And the VPC peer link carries control traffic between two VPC switches and also carries multicast and broadcast data traffic. In some link failure scenarios, it also carries out the unicast traffic. So the peer link needs to at least to 10 gig. This is gonna be 10 gig 10 gig interface on each side. And we have VPC domains. The VPC domain includes both VPC peer device, right, and the peer keep live link, and all port channels in VPC connected to downstream devices also associated with the configuration mode that you need to associate the VPC global. There's some global configuration. Then we have a VPC peer keep live link monitors the vitality of the peer switches. Right, you're gonna be monitor it, and the peer keep live link sends the periodic keep live messages between VPC peer devices. So the VPC peer keep live link can be a management interface or the switch SVI. So the node data or synchronization traffic moves over the VPC peer keep live link. So the only traffic on this link is message that includes the originating switch is operating and running the VPC. Next, we have the VPC member ports. The VPC member ports are the interface that belongs to the VPCs. So this lab will use the fabric controller to build all of that. So let's go to my fabric controller, close it. In the LAN, we'll double click the fabric, and navigate through switches. First click the spine one, take action, we'll make VPC pair. It's gonna be paired with spine 2, right? And we'll have a policy. They're gonna choose the VPC pair. To pair successfully, the value we recommend is the must be like true, right? So VPC will first build the VPC domain 200 in on spines, between the spines, and we're gonna put a keep alive local IP. So to keep alive, we use management VRF. Just note what this pair here. So the pair 1 is showing spine 2, pair 2 is showing spine 1. So my pair 1 keep alive local IP address should be exchanged to pair 2, and that gonna to match what is pair 1 and what is pair 2, right? So just it's very important to keep a note of it. That will keep everything else as a default. Click the VPC peer link. It's going to ask us to put in the peer link port channel ID. It's going to be 200 for sure. Next, it tells us to enter the peer link member interface. The peer link member interface for sure is going to be 1/1, 1/2. On both sides. I will leave the port channel mode as active. The peer one peer-link port channel description we're gonna leave as link to spine 1. As you might notice, the peer 1 is spine 2 and peer 2 is spine 1. So we're going to say the opposite, spine 2. Leave all other fields values unchanged. Now I'm gonna click save. I'm ready to set up the other VPC domain, which is the VPC domain 100 on the leaves, on the access switch. So I'll pick leaf 1 and click VPC pair. I'm gonna pair with leaf 2. Policy, we're gonna VPC pair. VPC domain, we're gonna pick 100. And it shows peer 1 is leaf 2 and peer 2 is leaf 1. So peer 1 keep alive local IP address. We're gonna to say 198.18.4.102. The VF is management. So we'll leave all the field values unchanged. Next, we'll take a look at the tab VPC pair link. The both pair ports channel ID gonna be 100. And take a look at the diagrams. We're gonna use saying 1, 1 and a 1, 2 for the peer link member interface. Port channel mode remain as mode active. And so click save. So now we're seeing the leaves and the spines are all pending for the configuration status. We're going to choose all the leaves and the spines, take action to deploy. And then we'll click deploy all. Come back to the switches after deploy all. We're seeing all devices in sync. Open up my my party session or open a leaf. First, we're going to show VPC. And go to my spine one. What I see as a peer status shows OK and a keep alive status are all alive. We'll now show port channel summary. I'm seeing the up in the port channel members. I will now configure VPC on the member port. First, we configure VPC on the spine 1 and spine 2 on the spine ports that are connected to the leaves. Then I configure leaf 1 and leaf 2 on the leaf ports that are connected to the spines. Coming back to my fabric controller. Here, we're going to click interfaces. We're going to take action to create an interface. What I'm trying to create is a virtual port channel. I'm going to select the VPC pair. Is spine 1 and spine 2. The VPC ID was set at 20. And the policy, we're going to pick a policy interface VPC trunk host. So it looks fine. And we'll check configuration monitoring. So enable this feature will replicate the configuration for both spines. And the peer 1 member interface. So peer 1 member interface, we're going to take a look here. It's going to be 1.3 and 1.4 on the spines. Because we click the configuration mirroring, and we are going to mirror the same ports. Enable BPDU guard, we'll say no. MTU will say default. So P1 trunk allow VLANs. We allow everything. We'll just type all here. Scroll down. We have nothing to configure, so we click save and click preview after. I'm gonna fix that. Save. Click preview. I'm seeing 18 lines pending configured, added. These are all the interface were configured for the VPC. Take care of that, and let's see the overall configuration. So all VPC configuration, and cancel, and we'll click deploy config. After that, we're going to show VPC on the spines. While I'm seeing the VPC ID 20 is done, but this will change after we configure the leaves. We go back to my dashboard and click the interface. We're going to create interface. The interface of VPC is going to be a leaf 1 and leaf 2. The VPC ID, we're going to use a 10. Interface VPC trunk host, that's fine. And we'll click configure mirror. So I can replicate the config for both leaves. The interface we're gonna do is the 1516. To go back here, 1/5 6. We don't want a BPU. MTU, we're gonna use default. For allow all VLAN, scroll down, we don't have anything to config. So click save. Save it successfully. Preview. So 14 lines pending to add. We're fine with that. Let's deploy. Deploy config. For all that, we're gonna OK to close it. Track our switches are in sync. Open up my CLM and in the spine show VPC again. Now port 20 is up. To go to leave, show VPC. Now port 10 is up. So right now we have VPC. This is configured between back-to-back spine leaf VPC. You have successfully configured spine leaf VPCs and is a back-to-back VPC. The next lab, we're going to configure VLAN interface with HSRP. So I'll review this lab topology and the nodes, or VLANs between the spine 1 and the spine 2. Are the gateways. So I have the VLAN 10 and VLAN 20. They are all HSRP, and the SVI interface for the gateway is as such. So in the lab, I'll configure the VLAN interface between the spine 1 and spine 2 with HSRP. So let's close it. We're going to navigate to interface. I'm going to create an interface. The next one I'm going to create is SVI, switch virtual interface. We're going to select the device. It is spine 1, and the VLAN ID is 10. Policy, we're going to pick the policy inter VLAN. In the general parameter, we're going to enter the VLAN interface IP 10.10.10.1, and the mask length is 20. So where's the HSRP IP? So now we get to advanced. We're going to enable HSRP, HSIP, IP before address, 10.10.10.254, group ID 10, priority we'll make it 50, enable permit. And then we're going to save the config. Then we'll click preview. And tells us it has 11 pending line config. It's just for HSRP. Cancel and click deploy. We're going to deploy the config. Close it. Go back to interface. Now we're going to add the same steps to spine 2. We're going to pick SVI, pick spine 2, VLAN is 10, pick out a policy. The general parameter with an VLAN interface going to be different, 10.10.10.2, /24. Check advanced, enable HSIP, 10.10.10.254. It should be the same across the spines, and HS group number is 10. We don't change HSRP priority, so it's going to be the secondary. Stand by and click save. Preview. It's going to add the HSRP configure to the spine 2. Cancel and deploy. We're going to deploy config. So now it's successfully configured HSRP on both spines. We're going to navigate to my spine switch. Show HSRP and log on to spine 2. In this case, spine 2 is a active, priority 100. The higher priority is going to be the priority. Then we're going to go back to the controller, close that. We're going to repeat everything for the other VLAN 20 HSRP. Save for the spine 1, deploy, deploy config. I've deployed, close it. I create the interface for spine 2. Now I'm going to show my HSRP on the spine 2 to show that active. On spine 1, it's going to be a standby. Now let's go back to my switches, show HSRP. I'm seeing both VLAN 10, 20, HSRP on spine 1 are standby modes, and my spine 2 is active mode. Go back to my fabric on the topology, double click in my classical. If you don't see the diagram looks like this, it might be a bug or gonna take some time because my port channel should be up for the spine 2 and leaf 1. That just sort of refresh multiple times and you will find the corrected topology right here. Okay. You can play around with this to look like what you want. In the next lab, we're going to configure OSPF between the CSRs and the spines. So the lab topology in here, we're going to make the OSPF connection between the spines and the CSRs. And the OS connection between the CSRs and spines is what we will use. I will add the configuration to the spines because I have already configured OSPF on the CSRs, and let's just double check. I configured interfaces and OSPFs, just like what it look like. All right. Let's go back to my dashboard, fabric controller. We're going to go to my fabric. We navigate policies. Let's add a policy. First of all, make a switch list. First of all, I'll pick this, the spine 1. I'll pick a template. The template I'll pick is OSPF. Pick a feature OSPF. And we're gonna save it for now. Add another policy. Still, we're going to pick spine 1. We're going to pick added policy, color base, underscore SPF. Click select. So in the OSPF process tag, we're going to enter 100. Go back 101 to 1 and click save. I'm going to do everything with it for spine 2. Still, future OSPF. Save. Add polys. Spine 2. Pick a base OSPF. Still 100. Rule ID 2.2.2. Click save. Action. Recalculate and deploy. Deploy all. Navigate to my CLI. I show OSPF. So run OSPF. I'm seeing OSPF feature is enabled and root ID is configured. So run OSPF. It is saying on spine 2. Next, we're gonna go close it. We're gonna navigate to switches. Want to double click is this spine 1. We're gonna find that interface. The interface is gonna be 1.5. Find this interface 1/5. Action. We're gonna edit the interface. So the policy we're gonna pick up is the called interface routed host. Select that. IP interface 10.10.40.2/24 MTU 1500. Keep scrolling down, and in free form config, we're gonna type IP router OSPF 100 area 0. Enter, no shut. This, go back to my diagram, is to config the IP address for the 1/5 interface. And we're gonna enable this for OSPF. We're gonna save it, and we wanna deploy. Deploy config. In the CLI, we're going to check if the interface configure, show IP OSPF interface. So IP also neighbor. We'll find a neighbor. That is the CSR1. Show run interface
Ethernet 1/5. We find all configured. Let's return to my diagram. Next to the interface we're going to configure on the spine 2 is 1/6. Go back to my dashboard. Close this. Double click spine 2 on the interface. Let's find out interface 1/6. There's a filter it device name where it contains spine -2. Let's find out other interfaces for spine 2. Find out interface 1/6. Action is added. Pick a routed host. Internet IP 10.10.30.2. 10.30.2 /24 1500. Keep the score down. Freeform config IP router OSPF 100 area 0. No shut. Click save. And deploy. Deploy config. So the configure has been deployed. Go to my dashboard CLI. Go to spine 2. Show IP OSPF. I'm seeing a process 100 through ID 2.2.2. Show IP OSPF. Neighbor is established with CSR1 also. Show run interface E16 and all configures. Let's take a look at my diagram. This time we're going to configure OSPF on spine 2 for redundancy link. It prompts the arrow for freeform, and we're going to double check. Missing the process ID. Save. Deploy. Now my configure has been deployed. Go to my spine 2. Show IP OSPF. Show IP OSPF neighbor. I'm seeing one more neighbor is added on interface 1/5 and show run interface E/5. The OSPF configure is enabled on this interface. For now, I have configured OSPF between the CSRs and the spines. Let's verify my topology. Close all. Go to topology. Let's refresh it a few times. Click spine 2. I'm seeing the connections to the CSRs. The one OSPF to the CSR1 from the spine 1. We should look at this like this. Okay. In the next lab, we're going to configure VMM. Then we're going to review the topology again. And we're going to notice the connection between the server and standard leaves. And I need that information to configure like the leaves and these VMM, the servers. Just to note here, I have UCS B server and with the FI Fabric Interconnect. To this Fabric Interconnect has a connection to my leaf 1 and the leaf 2, and what I've done there was server 1 and server 2. And on the UCS EXSI, we're gonna have a VNIC 1, VNIC 2. We're gonna put this in the visualization. So in any kind of troubleshooting, we're going to start with identifying network attachment points for the virtual machines. So that means we have to quick determination of the servers and the virtual switches, the virtual switches, and associated networks, port groups, VLANs, work out physical ports, and they are all critical. So this requires multiple touch points and interactions between the server and the network. You imagining a server at the main and network at the main, and we're gonna refer to multiple tools like orchestrator, uh, manage your network manager, network controller, so many tools. So this lab, we're gonna configure VM integration with my Nexus Dashboard Fabric controller. So this allows me to visualize the vCenter manager host and the leaf switches connections in this topology, right? So the visualization option includes a few viewing. So we're gonna see the physical hosts and the VMs. Once selectable to host and VMs, we the topology from the leaf switches to the VM, including the virtual switches, right? Virtual switches will show. So the UCS B server is behind the FI Fabric Interconnect. So jump back to my dashboard controller. I'm going to go to virtual management, click virtual information manager. We're going to take action to add an instance. It's going to be a vCenter. Type in the IP. Click add. Now the vCenter has successfully been added to the controller. Note that the server that I configured is added to the list and the status shows OK. Now let's go to topology. Configuration. Now I'm seeing the server 1 is behind a virtual server virtual switch 1, right? The server 2 is behind the vSwitch 2. We're gonna configure is the leave ports to the ESSi. Then for the ESS server, we're gonna ping the gateway and the web host. Let's jump to my controller. We'll go to LAN and interfaces. Filter my device name. X2, leave 1. The address we're gonna pick up is the 1/4. Pick one, leave 1/4. I'm gonna add it to the interface. Because of VMware, we're gonna pick the trunk host. For the policy, BBDU say no. Enable port type fast, we don't want it. MTU, use default. Trunk, allow VLANs, we use all. Click save. And we're gonna deploy. Deploy config. After deploys, I'm gonna jump to my CLI. I'm gonna click the server 1. I'm gonna ping 20.20.20.254. I'm ping up gateway. I'm seeing my Ethernet 1 interface that's on is in the VLAN 20. Getting response from a ping that confirms the server 1 can ping its default gateway. Next, because HSRP VIP is default gateway for the servers, I have to advertise it in the OSPF for the servers to reach the web host, which is the indifference to subnet. So now if I ping 10.10.10.1, I got a response. If I 10.10.50.10, log into my web host. The other subnet, I cannot ping it. Again, take out the right topology. I have to advertise the VLAN 20 to the OSPF and VLAN 10 to the OSPF in order for my servers to reach out to the web host. So that's what we're gonna do. Close this. Close again. Inside finding leave 1, I'm gonna look for spine 1. What I'm gonna find is the spine 1 VLAN 20. I'm gonna check this interface VLAN 20, and the action is to add it. So go down to the freeform config, you're gonna type IP route OSPF 100 area 0 and click save and click deploy. When I add this VLAN 20 into the OSPF, I'm deploying it. So after the deploy, I know I have configured OSPF only for the spine 1 to the OSPF for the VLAN 20. What I'm gonna do, close this. I will do the same for the spine 2. Check VLAN 20. Gonna add it. Go down, freeform configuration, IP router, OSPF 100, area 0. Save it. And we're gonna deploy. Let's take a look what I actually configured. Spine 1. Show around VLAN into 20. VLAN 20, I have OSPF configured. Then let's go to my spine 2. VLAN 20. VLAN 20, I have OSPF advertised. Now let's go to tiny my server one, and we're gonna ping is the web server. Now the web server, I got a response from the ping. We're gonna let it ping, and we're gonna go to leave one. I'm gonna have one more thing to verify. Let's show system internal L2 forward MAC. And I'm seeing a MAC address table like table for the L2 forward. If I go see ifconfig, I'm seeing the server one MAC address is this. I'm finding here the servers on VLAN 20 and port is to 1/4. As of for now, I have successfully configured VMM and VLANs. Okay, for the last part we're gonna do is to configure remaining VPCs. Let's take a look at the diagram. I know to the VPC connections between the servers 3 and I leave 1 and 2. I need to configure this VPC for my servers 3 port channels. So I must configure the VPC and I want to test the connectivity from server 3 to the web host. First thing I'm gonna do, let me go to my fabric. Go to interface. Now we're gonna create interface. We're gonna pick a virtual port channel. Pairs the leave 2 and 1. VPC ID. We don't use mirror at this time. So for the leave 2, we're gonna pick up the 1/4, and peer 2 should be leave 1. Then I'll pick a 1/3. At BPTU, I say no, I don't want to enable. MTU, I'm gonna use default. Peer 1 or trunk allow VLAN all. Peer 2, trunk allow VLAN all. Click save. Let's view it. For leave 1, I'm configuring port 1/3 at the port channel. Leave 2, I'm configuring port 1/4 for the port channel. Cancel that. I'm okay with the config. Deploy it. Deploy. After the configure has been deployed, I'm gonna navigate you to my leaves. Show VPC. Port channel 55 is up. Go by leave 1. Show VPC. Port channel 55 is also up. Let's open up my server 3. Let's see if we're gonna be able to ping 10.10.10.254. Yes, I am pinging my gateway. While I'm ping, I ping 10.10.50.10 is the web server, external web server. I can't. So I will gonna to also advertise VLAN 10 to the OSPF. That search box, spine 1. Let's find out that interface VLAN 10. Check it. Gonna add it interface. Scroll down on the freeform configuration on the IP router OSPF. Save. I'll put it into OSPF. I'm gonna deploy it. We're gonna close that. We're gonna continue to filter out spine 2. Find out that VLAN 10 interface. Added interface. Close it. Somehow the dashboard controller doesn't have any information on my VLAN 10. Don't worry, I'm gonna add it. Save it. And I'm gonna deploy it. Go to my spine 2 CLI. I'm seeing the router OSPF is advertised to VLAN 20 and VLAN 10 is also in place. Check again HSRP. I'm seeing all the HSRP active modes for spine. Then let's go to my server 3. Ping 10.10.10.254. For sure the gateway is working. 10.50.10. The external server is also responding my ping. So the server 3 is up and running, and the port channel is also in place.